sports figures. Put your brain in the game.
Tennis is a game of angles, right? Like when you serve, you want to make sure you get plenty of height on the ball so you get the best angle into the service box. Oh. See, the reason that you want the ball up high is so you get a nice straight shot into the service box. See, in tennis, you have to hit the ball from back there at the baseline, diagonally into the service area. That's why you see them reaching as high as they can, jumping to get to the ball. So if you want to improve your serve, it'd be great to know exactly how high up to hit the ball. That way, every serve would be an ace. Ah. To help us with our serve, we've got Malavia Washington. He's a 1996 Wimbledon finalist and a member of the '96 U.S. Olympic tennis team. He's also a commentator on ESPN and the president and founder of the Malavia Washington Kids Foundation. So he knows all the angles. Hey Mal, would you give us a little service lesson?
Well, the first thing I think of when I hit a serve is I have to have a good ball toss, because if I don't, I'm not going to have a good serve. The second thing is when I make contact with the ball, I want to be fully extended.
Well, what about jumping to the ball?
Well, when I jump up off of the ground on my serve, that allows me to get full extension.
But you know how high exactly you have to be to hit a ball straight into the service box?
That I don't know.
Well, that's what we're going to figure out using geometry and triangles.
Let's find out.
Okay. Okay, guys, how are we going to figure this out?
Couldn't you run a string from a pole at the baseline into the service box?
And then just measure the pole.
Yeah, we could do that, but I mean, I'd have to get up and get a pole and find some string, and it just sounds like a hassle. Why don't you guys do that? I can figure it out without even leaving my seat.
How are you going to do that?
I'm going to use triangles. We can compare results later. Come on. Okay, here's our problem. We want the ball to follow a straight path from the baseline to the back line of the service court, like this. We can make a right triangle. What we're looking for is the length of this side of the triangle. That'll tell us how high the ball has to be. Let's take a second to talk about triangles. A triangle is a plane figure formed by 3 segments joining 3 points that aren't on the same line. Each point where the lines meet is called a vertex, and each segment is called a side. Now, there's a whole bunch of different kinds of triangles. You got your scalene, your isosceles, your equilateral, your right triangle. But what's so great about triangles is that we know so much about them. Stuff like all 3 angles have to add up to 180 degrees, and in a right triangle, you can use sine, cosine, or tangent to figure out the length of the sides or the angles. And there's the Pythagorean theorem, which can give us the length of the hypotenuse in a right triangle. So if you can make a triangle out of any situation, you can solve just about any problem.
What's your problem?
Well, almost any problem. We can solve our tennis serve problem using similar triangles. We can draw a second, smaller triangle from the net to the end of the service court. These triangles are similar. They're different sizes, even though their angles are the same. When 2 triangles have the same shape, same angles, but they're different in size, they're called similar. It's like when you blow up a photograph. The original and the enlarged photo are similar because they have exactly the same shape. But they're not equal because they're different in size. The same is true for our triangles. One is just a blown-up version of the other. To denote similarity, we use a symbol that looks like this. Similar, but not equal. See, the thing about similar triangles is that the corresponding sides are in proportion. They make a ratio. We can take a look at proportions this way. Let's say for every 2 feet I go, Lauren here goes 3. So I'll go 2 feet and Lauren will go 3 feet. Now I'll go another 2 feet and Lauren will go another 3 feet. See, Lauren is moving farther than I am, but her movement is proportional to mine.
3 to 2.
Right, and what's that called?
A ratio.
Right. Ratios can be expressed like we just did, 3 to 2, or as a fraction, 3 over 2, or as a decimal. You simply divide by the denominator. So 3 divided by 2 is going to give us 1.5. If we knew the length of 2 sides of our small triangle and one of the sides of our big triangle, we could create a ratio that would tell us how high the ball has to be.
But to get the lengths, we still have to measure the size of the smaller triangle.
Yeah, it's the same as the string and the pole.
Our measurements are already done.
How?
We already know the dimensions of a tennis court. That's all we need. We know from the net to the service court line is 21 feet. And we know the center of the net is 38.5 inches high. So to give the ball room to get over the net, we'll call it 41 inches. And from the net to the baseline is 39 feet. We get 21 feet and 41 inches for the sides of our small triangle. If we add the length of the service box and the distance to the baseline, our big triangle has one side of 60 feet. And the other side is what we're trying to figure out, how high the ball has to be. So we'll call it X. Because we've got both inches and feet, let's convert everything to inches to make our lives easier. Now we have the sides of our small triangle and one side of our big triangle. Because of that, we can make a ratio. The ratio of our 2 horizontal sides is 720 inches to 252 inches. That's the same as 720 over 252. Because we have similar triangles, we know that the same ratio has to apply for both our vertical sides. One side is what we're trying to figure out, so we'll call it X. And the other one we know is 41 inches. So we get a ratio of X to 41, or X over 41. We know these ratios have to be equal. To solve for X, we just cross multiply, right? X times 252 gives us 252X. 41 times 720 gives us 29,520. That gives us 252X equals 29,520. To get X, we just divide, and we get approximately 117 inches. That's it. That's exactly how high the ball has to be hit to go straight into the service box. Yes! See, I did it all without even leaving my seat.
Wait a second, so you end up with 117 over 41 and 720 over 252, and that's the same ratio?
Yeah, you can double check it like this. You can convert the ratio to decimals by dividing 720 by 252 and 117 by 41 and finding that they're both 2.85. Or we could have simply found a decimal for our first ratio, 720 to 252, 2.85, and then multiplied 41 by 2.85 to get 117. Okay, Mal, it all checks out. You have to hit the ball at 117 inches. That's about 9 feet 9 inches.
Okay, but there's only one problem. That's too high.
What do you mean?
Well, that's too high for me to hit the ball.
But that's where you have to hit the ball if you want to get your serve in. How tall are you?
I'm only 5'11".
Oh, I guess you have to be 6'5" to get your serve in.
Well, I'm not 6'5", and I get plenty of serves in, and there are a lot of players shorter than I am.
All right, why don't you show us where you hit it?
Okay, I'll do that.
Oh, Mal hits the ball at 110 inches off the ground. Ugh. If the ball traveled straight, it would end up way long. It has to. Super hard, fast serves really look like they're going straight in. But if we slow things down, we can really see what's going on. Hey, Catherine, slow it down. It's actually traveling in an arc, a curve, and that arc is called a parabola. So, Mal, are you doing something to get the ball to arc down like that?
Actually, I'm not.
Well, then how come it drops?
Well, it arcs down because of gravity.
Gravity, of course. Yeah, gravity's always working on the ball. But it's going so fast. I mean, you are hitting it. What's your fastest serve?
Well, my fastest serve is about 125 miles an hour. And what about yours?
You know, 126, 127.
Really?
That That means that as the ball travels from the baseline to the service court, gravity's going to pull it down about 2.5 feet. That's more than enough to compensate for the 7 inches that Mal was too low. So even if you wanted to, you couldn't hit the ball straight in.
That's absolutely right, because gravity is always going to take the ball down.
Okay, guys, so what did we learn?
We can use similar triangles to solve problems.
Similar triangles are the same shape, but a different size. All their angles are the same.
And if they're similar, then their sides are in proportion, and you can make a ratio between them.
And that ratio will be the same for all the sides.
Most tennis players can't hit the ball high enough to make it straight into the service box. So you have to rely on gravity to bring your serve into the service court.
Okay, great. Well, that's it. We'd like to thank Mal Washington and our students, Catherine, Robert, Lauren, and Donald, for helping us out here today on ESPN Sports Figures, the Tennis Triangle.